So Abhinav is saying yes. Abhinav, can you share your screen and can you show the same thing for others so that they will have some idea? Abhinav, can you hear me? Or else Sobia, can you hear me? You can also share your screen and show to others the content and all.
Yes, sir.
Yeah, yeah. So just share your screen, please. And well, so yeah, thanks, Sobia. So I'm talking about this. Manoj, can you see the Sobia's screen, right? That
Yeah,
all
yeah,
the
we can
lectures
see that.
video. Yeah, yeah. So that for the same I was talking about actually. So my question was how many lectures from there you guys have covered. So that was the my question. Thanks, Sobia. So, I mean, have you covered any lectures and also accordingly we'll start this. I mean, anyway, we have covered till week
Yes, sir.
three.
Till 3 weeks.
Yeah, till 3 weeks in the last session. Okay. Okay. Did you get the recording of that session or not? Via mail?
No, sir, we did
Not
not
yet.
get.
No. Okay. Okay. Then I need to cross check with the team because I had already informed them. No problem. I will cross check again with them. They will share. Okay, so let me start with the week 4 here. Okay, so I will try. Okay, so I have collected some questions which will cover the more or less every concepts and we'll try to solve that question. And everyone, please be ready with some pen and paper. We'll try to solve some questions and we'll try to understand the concepts of. I mean, till week 8. So today's plan is I will try to cover the concept till week 8. Okay. Okay, so everyone, please ready with the like pen and paper. I'm just going to share my screen. Yeah, okay. So let me just share my screen. Is my screen visible to all of you?
Yes, sir.
Okay. Well, thank you. Okay, so today's we'll try to cover the. Okay, so in last week, I mean last session, we have discussed these some questions. These PDFs, I had shared already with the team. Maybe I need to remind them again. They will share with you. So these were the some questions which we discussed in the last session. This PDF will be shared with you. Okay, no need to worry about that. Okay, so today's okay, we are going to discuss this something. Okay, meanwhile, let me tell you. So in week 4, okay, this very first question is from week 4. In week 4, okay, let me give you some idea. Till week 3, right? Uh, in week 1, we discussed something about data, categorical data, and all, right? In week 2, what we had seen? We seen the graphical visualization or representation of this categorical data. In week 3, we discussed about numerical data and some graphical representation. And for numerical data, what are the measures of central tendencies and all, right? Measures of central tendency means mean, median, mode and all. Then measures of variation, I mean spreadness and all, that variance standard, those all are things we have discussed. We discussed what are the percentile, quartiles, everything, what is the interquartile range. Okay, now in week 4, what is the main thing? So far we have seen, right, categorical data, numerical data and all, but uh, so that was for a single kind of data. So in week 4, what are the major topics? First topic is how we can find the association between two categorical data, right? So very first thing is we have to check association between two categorical data. Okay. And second one is association means kind of, you can say, a dependency, right? Means association means, suppose I have two variable, for example, let's say one is x or one is y something. So how they are associated to each other, associated, or how they are dependent, or how they are related to each other. So related means if I'm going to make a change in another first variable, that means it will affect the change in another variable, right? Then only then I can say these two are dependent. Yes or no? Independent means whether you are going to make any changes in the first variable, that will not reflect any changes in the second variable. Okay, but if I'm saying both variable, both things are associated, that means what? Both are related to each other. Means if I will do some changes in first one, that means it will reflect the changes in some changes in second one also. Yes or no, right? You can simply say, let's say age and weight of a person, right? Or age and the height of a person, income and expenditure, something like that, right? So that is the numerical variable, but I'm just trying to give you some sort of idea what is the meaning of association. Is this fine, right?
Yeah.
Okay. And another is, we will in week 4 measure is association between two numerical variable. Okay. And then third one, see, here we are going to see two categorical, two numerical, but is it possible to see association between one numerical and one categorical, right? So these are the major things which you will see in week 4. But as of now, as the I mean, as point of okay, so there is two things you will tell me. What should we prefer actually? So should we discuss only that topic which is going to come in the exam, or should we discuss whole week? I mean, what's your preference? I can discuss, it will take some time, not a problem. But I've taken the only that question related to that topic which is going to come in the exam from the week 4 actually. So should we discuss that, or should we discuss all?
Which is coming on the exam.
Okay. Exam topic. Okay, okay. So actually, see, don't think like this. These are the not important. These are the important. I'm going to discuss only this association between two numerical variable. So there is association between one numerical variable, one categorical variable. That's also important, because whenever you will go in, right, real field, real when you are going to apply anything in with real data, right, you should know how first of all you have to identify what is the categorical data and how you can find the association between that thing, right? Let's say I'm saying, okay, I will give you the idea. I will just give you some 5-minute idea, then I will move to the this question. Okay, so categorical data means what? On which I cannot perform any mathematical operation, right? Okay, so let's say one categorical variable is gender, let's say female and male. Okay, and another is, let's say I'm going to take whether they are interested to go for higher go for higher education, let's say abroad or not, something like that, whether they are interested for higher education or not. So if I'm talking about interest, so there will be two things, right? Yes, no. Yes or no? Correct. So this gender, you can see, this is also categorical variable. This has only two category, male and female. I cannot perform any mathematical operation, right? For higher education, yes or no, right? This is also a categorical variable, right? We cannot perform any mathematical operation. So in association for, okay, so what, I mean, what will be your objective? You will be interested to know whether this gender is associated with higher education or not. Okay. So there is a method called contingency table, and you have to calculate by making that contingency table. It's you have to calculate row relative frequency and column relative frequency. So there will be some numbers, right? Let's say some 10 females are going. I mean, you have done some survey, and 10 out of 10 female out of them, they are saying to, they are willing to go for higher education. Let's say 5 are saying no. Let's say 20 men are saying to go, and let's say some 10 are saying no, something like this. I'm just assuming some hypothetical data here. So there is two methods called row relative frequency, okay, or column relative frequency, okay. And we know what is the relative frequency from week 2 is nothing but frequency divided by total, right? Yes or no? This is something we have seen, correct?
Yes, sir.
So if you see, I'm talking about this called method. If you will emphasize on the word row relative frequency, I'm talking about row relative frequency. So that means, so this total, right? So I'm talking about row total. So this will be 15, this will be 30, right? What is this grand total? 30, 15, and this is the 45. So far so good, right? So what you will do in the next, what you have to do, you have to calculate the row relative frequency. So what we have to do while calculating the row relative frequency, so this is the 10, right? This is the one of the frequency, okay? And what is the row total? 15 for this row, correct? And then 5 by 15, then for this row 20 by 30, then 10 by 30, and for the grand total row 30 by 45 and 15 by 45. Are you getting some idea? Okay. Yes, no, anything?
So this is row based, I think.
Row based, yeah. In relative frequency, how we are calculating? We are dividing the frequency divided by grand total, right?
Yes.
Correct. So here I'm talking about row relative frequency. So for each row, what is the total? This is 15. For this row, what is the total? 30. Correct. And for this last row, it is what is the total? 45. Right. If you see, we are dividing each frequency, I mean each count by that particular row total. Correct. Okay.
Yes.
So, okay, what is the method? I'm not going to in that depth. You can watch the lectures video because we'll focus on the topic which is going to come in the exam. So, what is the method? Method says if all row relative frequency means you calculate. Suppose this is coming out to 0.20, 0.10. I'm just taking randomly. So you have to divide this value. You will get if all row relative frequency, okay, are different, right, are significant difference, then you will say gender and higher education are associated with each other. Okay. If all the row relative frequencies are approximately same, then you will say gender and higher education are not associated with each other. Okay, this is the method. I will just tell you one graph. Okay. So what is the meaning of that? So that is called 100% stacked bar chart actually. So if you, what is the meaning of, if see what I'm saying, all row relative frequency are same. Okay. Then no association. Well, so what is the meaning of, suppose this is the female and this is the male. And what I'm saying, suppose I have calculated 100% stacked bar chart. 100% stacked bar chart means I'm not talking about in numbers. I will talk about in percentage, right? So what do you mean by suppose here you are doing 10 by 15, right? If you multiply it by 100, you will get the things in percentage. Yes or no?
Yes.
Right? So for example, for male and female, suppose I'm just taking randomly what I'm just trying to say something. Suppose this is the case. Well, and suppose this is some sort of hair. Well, okay, this is the red, and let me make it as a green part. Okay. Okay. So suppose this green means they are ready for go. Yes, yes. And this means suppose no. Okay. Now, if all row relative frequency are same, right, then you will get the some sort of graph like this. Okay. So I told you, right, if all row relative frequencies are same, then what do you mean by no? So I'm saying here it's a no association, because if you see, if you are going to make a change, is there a significant change in yes or no, or is it approximately same? It seems approximately same, right? You can see the red part, red portion, and green portion.
Yes.
Yes or no? Are you getting what I'm trying to say, right? Because sometimes people have a doubt, why if I'm saying same, then what's the no? What's the meaning of no association? That's why we are saying. For example, instead of this, suppose I got the graph like this. Suppose this is the yes part, okay, and this is the no part for men. And somehow suppose this is a yes part, for example, yes. Now, what you can interpret from this graph? Row relative frequencies are same or different?
Is it different?
It's a different, right? Then I will say association is there. Okay. Is this some sort of idea is okay? Right? Is this clear? Some sort of idea is fine to all of you? Are you getting something?
Yes, sir.
Okay. Right. Oh, fine. So I'm moving to the next topic actually. So this is something called association between two numerical variable. We will see. So this is for categorical variable. You can watch the lectures with you. That will help you. But I have already given some idea. So that hopefully that will help you. So I will just give me a second. Okay. So we will see the association between two numerical variable. So how I can see that actually? So actually to see the association between two numerical variables, so first one is called covariance. Okay, very first thing is you can plot a scatter plot. Okay, on the x-axis, the variable you can simply keep which is independent. On the y-axis, you can normally we are taking which is dependent. So scatter plot means suppose you have plotted your data, for example, your biochemistry or something like that. I'm talking about in general. So suppose you are getting the graph something like that. Okay. So what you can interpret from here? There is
like,
some positive correlation, right?
yes.
Yes or no? Means, so
Yeah.
what is the meaning of positive correlation? Means if I'm going to, if one variable will increase, another will also increase, right?
Yes.
If suppose you are going to get something graph like this, that means what?
Is a negative.
Negative correlation, right? So if one is increasing, another one is decreasing, right? If
Yes.
I'm going to get a graph, suppose I got a graph something like this, something like what you can see, what you can tell me?
It's a random actually.
Random, no pattern, right?
Yeah.
Okay, yeah, well, fine. Now, so okay, so actually one more thing. So for numerical variable, one more thing is called covariance. Okay, so this covariance actually gives us the tells us the association between two numerical variable. Okay. So what is the formula? I'm just going to tell you. So let me define the for population covariance formula between x comma y. It's nothing but 1 upon small n summation I is equal to 1 to n xi minus x bar into yi minus y bar. So this is the one numerical variable. This is the another numerical variable. And for the sample correlation formula, sorry, covariance formula, it's nothing but 1 upon, as you seen for variance, right? We are using in the denominator n minus 1, right? Okay. So it will be xi minus x bar, yi minus y bar. Don't worry, it will be clearly mentioned. If question is there, then it will be clearly mentioned whether you have to calculate the population covariance or sample covariance. Okay. So, but let's try to understand the concepts here. Okay, so what is the thing here? So see, if you see, so this covariance formula, right? If you see this covariance between x comma y, it can be positive. Okay, it can be negative and it can be zero also, right? Whenever you will calculate it, you can get a positive correlation, negative covariance formula, and zero also. So if I will say, if I'm getting the positive, right, that means what? I will say these are the positively associated, right? Or if this is this will give me negative value, I will say this is the negatively associated. Well, and zero means
Not associated. Is no
no,
pattern.
no linearly related.
Yeah.
Why I'm emphasizing on the word linearly? Because covariance just tells us the association between two new. Okay, sorry, I forgot. It just tells us the linear association. Okay, it's possible covariance between x and y is zero, but y and x are there. There is some relationship. Let's say y as a x square and something like that. Okay,
Okay.
so these are the
It's like a
major things.
quadratic equation.
Quadratic equation, but covariance can be positive. Covariance tells us about only linear association. Okay,
Okay.
but major idea is we have to think. Uh, just a minute. Let me see whether I have page or not here. It's a full page. Okay, let me write here. Okay. Okay. So major, let's say this covariance value, right? It can be anything, right? It can be 152, let's say 230. You can get minus 72, minus 170 for some different data set. Okay. But see, main point is then what's the use of correlation, right? Correct. If covariance gives me idea about association between two numerical variables, then what's the use of correlation? Anyone, any idea? Any thought if you know or something? No? Okay, no problem. See, covariance, it gives me the value, right? So here, if I will see 152, I will say it's a positively related. If I will see 230, I will say it's a positively. It's minus 70, minus 170. But how much, right? See, you can't say this one is the higher or this one is the lower or something like that, correct? Because we don't know the strength, right? Because there is not any upper limit and lower limit for covariance, correct? You can get any kind of value, but see, how will you define the strength? So that is something correlation coefficient comes into the picture, because in what is the what is the formula for correlation? First of all, it's a unitless. So for correlation formula, it's a, we are saying covariance between x comma y divided by standard deviation of x into standard deviation of y. This is
Right.
the formula. If you see what is the covariance formula, so for covariance, you can simply see, let's say x is age, then y is let's say weight of a person. Then what will be the unit for a? It will be year into kilogram, right? Then for standard deviation of x, again it will be year, and standard deviation of y, kilogram. Actually, unit will get cancelled out. So
Cancel.
so this R is unitless measure actually, first of all. And one in base, very important thing, the range for R is, it will lie between from minus R to, minus 1 to plus 1. If you have calculated R and it is very close to 1, you will say it's a strong positive correlation is there. Okay. If R is very close to minus 1, you will say strong negative correlation is there. So here you can define whether it's strong, weak, moderate, because I have upper limit, I have lower limit. Yes or no? But in case of covariance, we don't, right? So what is the exact formula of R actually? Let me tell you. So you can see, let me derive, erase something. Okay. So why emphasizing on the R? Because you can see we have the question related to R. R means correlation coefficient. Okay. Well, so let me tell you. So as I told you, R is nothing but covariance divided by x comma y divided by standard deviation of x into standard deviation of y. So here in this question, it has been asked what is the correlation coefficient between the marks of both exams paper. Means what is the biology, chemistry. You can simply define x and y, whatever. Now,
Yeah.
so thing is that in the numerator is the covariance of x comma y, standard deviation of in the denominator standard deviation of x, standard deviation of y. So one final formula for R is, see, in the numerator it is not mentioned, right? Which one is the population, which one is the sample, right? So what you can do, you can simply, you can put any value, anything means if you are using numerator, in the numerator population covariance formula, then make sure in the denominator also you are going to use the population standard deviation formula. Or if you are going to use sample covariance formula in the numerator, then make sure you are going to use sample standard deviation formula in the denominator. Why? Let me tell you. So in the if you see in the numerator part, right, what I can write, 1 upon n summation of xi minus x bar yi minus y bar. Yes or no?
Yes.
Right. Now in the denominator, what is the standard deviation of x means? Let's say I'm using population, then it will be 1 upon n summation of xi minus x bar whole square, right? And then the denominator 1 upon n summation yi minus y bar whole square. So far so good. If you've seen, I have used the population covariance formula and population standard deviation. Well, is this clear till now?
Yes.
Okay. So I will tell you the final form of the correlation formula. Just give me a second. Let me erase all these things. Then I will uh, I will move focus on the formula itself. Well, so if you see, this 1 by n will get cancelled out by these two 1 by n, because in the denominator is in square root, right? Yes or no? See, square root of 2 is square root of 2, it will give you 2. Correct?
Yes.
Correct? Now, so if you see, what is the final form? R is nothing but summation of xi minus x bar into yi minus y bar divided by square root of summation of xi minus x bar square into square root of summation of y minus y bar square. So you can, if you want to use sample, it will be n minus 1, it will be n minus 1, it will be n minus 1. Again, 1 upon n minus 1 will get cancelled out. So final form is this one. Fine. Now, so by using this, so what is this x bar? X bar means mean of this observation. Y bar means mean of this observation. So what you have to do? You have to 20 minus mean, 25 minus mean. You have to do like this. Okay. So now by using this formula, okay, just take some 4 to 5 minutes and calculate and let me know which one, what will be the answer. Okay. Formula is fine to all of you. Okay, this is something you will get some sort of practice also. So that's why I'm asking. Okay, everyone is trying, right? Just let me know if you are not getting anything or something like that. Okay, it shouldn't be like that. I'm just waiting. Yeah, you are trying, correct?
Yes.
Okay, well. Okay, thanks. Just try.
Not sure I'm getting answer as infinity. 0 by.
No, then it's you're making something wrong. Yeah.
Okay.
Sir, x minus xi sigma xi minus x bar is getting 0.
Same with y.
Okay. Then it's fine, right? If you are getting xi minus x bar something is 0, that means what? You are getting 0 by something, correct?
Which is infinity, right?
Which is equal to 0. Yes or no?
Okay.
Okay.
Not in. Okay.
Yeah.
0 then.
Let's see answer.
Okay.
Answer is 0.32, but maybe you are making some mistake. Let me do it on Google Sheet. That will save our time. Okay, I'm not going to do it like that. Will that be fine, right? Just tell me the observations. 20, 25, 30, 35, 20, 25, 30, 35, and 40, correct?
Correct.
And then it's uh,
25, 20,
25, 20,
30,
30.
20, 30.
Okay, well, thanks. So there is something direct you can apply the one of the called correlation function, but you will not get Google Sheet in the jam. But I'm just doing directly. Yeah, 0.32 is the correct answer if you approximate. Let's do like this with the usual formula. So first of all, you have to calculate the average, right?
30.
So this is the
30.
30, and if you
20.
calculate the average for second, it will be 25, right? So next,
Right.
what you have to do, you have to do
Same minus x
xi
bar.
minus x
X bar.
bar, right? So we have to fix this x bar because we have to subtract.
Right.
So this will be case.
So it will be summation will be 0 here.
No. I think I got you. What's your mistake? See, we have to do summation of xi into x bar in xi minus x bar into yi minus bar, not summation of xi minus x bar, right? That was
Okay.
your mistake. You have to do xi minus x bar into yi minus x bar, correct? Then you have to take the summation. Understood?
Okay.
Okay. So it's a yi minus y bar.
Right.
So yi minus
I got 0.18 the answer.
1 second. So you can simply take, you have to take the product of these two, right? If you see,
Oh,
if you take the product of these two, it's something like that.
okay. Okay.
1 second. Then summation of these two, it's coming out to be again 0. No, it's a 50, right? Now you can check, right?
Yes, sir.
So numerator part is 50. Similarly, for the denominator part, what I have to do? I have to take the xi minus x bar square, right?
Right.
Correct. Then
That summation is 50, 50.
yeah,
And
correct. Then yi minus y bar square. So then you have to take simply you can scroll down, and if you take the summation, this is summation. Then basically I have to take the square root of this summation, correct?
right.
Well, and then you have to do like this. So if you see,
Yeah, 0.31645.
correct. So that is something. Now you understood, right? How to calculate, correct?
Right.
Okay, well, yeah. So this is something you can go at, right? Fine. Okay, so 0. Yeah, so in the question it mentioned we have to approximate till 2 decimal places. If you are getting 0.316, that means it will be 0.32. Well,
Right.
yeah. So let's move to this next part question. 5 dice are rolled simultaneously. How many of the outcomes will the third and fifth die turn up, a 6 or 1? Before this, let me tell you something called counting principle, right? So what do you mean by counting principle? Suppose there is an event, there is an action A which is going to occur, let's say, in 3 ways. For example, let's say there are 3 shirts, for example. Okay, let's say black shirt, blue shirt, and white shirt, or let's some other color, black and let's say gray shirt and white. And there is a B action which is, let's say, your 2 pants. For example, let's say black and any other color, let's say black or gray, or so let's say blue itself, for example. Now, if you see, now if my question is, you went to a shop, a small shop, and there is 3 shirts of your size and 2 pants. Okay, in how many ways you can purchase or you can buy a shirt or a pant? Be focus on or word. In how many ways you can do? Can you think before going to the formula? Right? I'm saying you can simply purchase a shirt or a pant. In how many ways you can do? Anyone? I think it's very simple mathematics, right? Siddharth will share these papers. Don't worry. After the end of session, we'll share. No need to worry about those things. Just try to be focused here. Can you tell me in how many ways? I'm saying in the shop there are 3 shirts and 2 pants. In how many ways you can purchase a shirt, either a shirt or a pant?
Three C5 plus 2C5.
Okay, why you have used 3C5? Or just think, is it correct to saying 3C5? What do you mean by 3C5?
Selecting 3 shirts from 5 pants, a total of.
No. Then it's a 5C3.
Okay, I'm sorry.
Okay. Okay. It's a very basic called counting principle. It's a very basic thing. See, what I'm talking, I'm emphasizing on word or, right? If you see, if you simply say, I can purchase either a shirt or pant. If I'm going to purchase a shirt, then in how many ways I can purchase? Either I can purchase a black shirt, right? Correct? Or I can purchase a gray shirt, or I can purchase a white shirt, right? Yes or no? If I'm going to purchase a pant, either I can purchase a blue pant or black, right?
Black.
So what are the total ways? I have 1, 2, 3, 4, 5. Total 5 ways, right? So there is one formula which is called, if there is action A which is occurring in n1 ways and action B is, can occur in n2 ways, Okay, then in occurrence of A or B will be in how many? N1 plus N2
And
ways. You can simply say here, for A, what is the number of ways? It was for 3. For B, it was 2. Then total ways was 5, which is 3. You can say N1, 2 is N2, N1 plus N2, 5. Is this clear? So it's a or. Or means we are going to add, right? Is this clear?
okay.
Okay, let's move to the next concept. Okay, so these all things you will see in the lectures video. I thought you people have seen already, but no worries. It's very basic counting principle, and also we'll try to go with the. I will try to explain and we'll try to solve the questions. Okay, you to just focus on the statement of the question. Okay? Now tell me with the same example. Suppose I'm saying event A. A means suppose there are 3 sorts, right? Which let's say black, gray, and white. The same thing I just trying to explain. 2 different pants. Let's say black and blue. Okay, are you able to understand my writing here? Right? Is this fine, or because I'm writing a little bit fast?
Yeah,
Is
it's
this all
fine.
right? Okay. Okay. Thanks. Okay. So be focused on the statement. What I'm saying. In how many ways I can purchase a shirt and a pant? Now, tell me. just take a 1 minute. Just think. It's basic, very basic counting.
So it will be 6. It will be N1 multiplied by N2 if I'm not wrong.
Correct. So before going to a general formula, let's discuss like this. So it's
Yeah.
talking about sort, right? Okay, let me write sort. I'm just going to write S1, sort 1, sort 2, and sort 3. Okay, I mean this black, gray, and white. For pant, P1 and P2. This black and for our simplicity. Okay. So it is asking about we can purchase and, right? That means I can purchase a shirt, right? And pant 1, yes or no? Then shirt 1 and pant 2, yes or no? Then you can simply say you can purchase shirt 1 and pant 1, then shirt 1 and pant 2, correct? Then S3P1, S3P2, I mean talking about you can simply purchase S1, shirt 1, pant 1. See, you can see and 1 shirt, 1 pant. Or what you can purchase S1, P2. Or you can purchase S2, P1, S2, P2, S3, P1, S3, P2. Yes or no?
Yes, sir.
What is the total number of ways here? 1, 2, 3, 5. I mean 3, 4, 5, and 6, right? 6 ways, correct? So you can go with the formula itself. Means you have to purchase a shirt. In how many ways you can purchase? Okay, here let's think. How many in what is the total number of ways you can purchase a shirt?
3.
3. And means multiplication. In how many ways you can purchase a pant? 2, which
2.
is 6. Okay. In general, if there is an event A which is going to occur in N1 ways and event B which is going to occur in N2 ways, then event A and B can occur in N1 into N2 ways, which is called multiplication rule of counting. Well, fine. Okay. Now, is this all right? This addition and multiplication?
Yes.
Okay. There is one more thing called factorial. I will introduce, then I will move to the, will try to move to the next part. Okay. So we'll try to see the questions and all related to that. Factorial, and I will try to explain permutation and combination, and then we will move ahead. Okay. Maybe permutation combination you people have seen before this, but yeah. So, okay. So what is the called factorial? I will not go into that mathematics. I will just tell you the formula. So basically factorial is something. Suppose I'm saying n factorial. So how this n factorial can arrange? So it's for arranging. Okay. So this n factorial I can write n into, next one is n minus 1 into n minus 2 into up to 3 into 2 into 1 till 1. For example, this is nothing but number of arrangement, you can say, right? Now, means number of arrangement, suppose you have 5 people or 5 chairs or 5, let's say 5 chocolates or something like that, and you want to arrange in a row. Okay, I mean, for example, let me try to explain with the example. Suppose you have some 5 pen, okay, or let's say 5 books you have, and there are some 5 places, okay, 1, 2, 3, 4, and 5. In how many ways you can arrange these 5 books at these places? So what you can do for the first place, what are all options you have?
5 options.
All 5, right? You can arrange, you can take any of the 5. And for the second place,
You have 4 options.
4. For the third place,
3
you will be having 3. For the fourth, you will be having 2, and for the last, you will be having 1. So this is called the 5 factorial by this formula. Okay. If you want to write 4 factorial, that means 4 into 3 into 2 into 1. So you can simply replace n with 4. Then n minus 1, that is 3. Then n minus 2, that is 2, and 1. Okay. Some sort of idea is okay.
Yeah.
Okay. So it's about you are going to arrange, right? You are going to arrangement. Okay. You are going to do the arrangement. Okay. Next one is called permutation. Okay. Actually, permutation and combination. So there is a very okay. Any one of you from your previous knowledge or something, can you tell me what's the difference between permutation and where we should prefer permutation and where we can prefer the combination?
For seating arrangement, we use permutation, and combination is used for selection of people or group.
Yes. So one key difference is, let me tell you, permutation and combination. Okay. So in permutation, right? So order matters. Okay. And in combination, yes. And in combination, sorry, order doesn't matter. Okay. I will let you know the formula and all. Okay, let me try to explain the things. So what do you mean by order matters? Suppose in permutation, so here you can see the arrangement, right? If I'm saying I have an object and distinct object, right? If I want to arrange R objects, then I can do in NPR ways. What is this NPR ways? Okay, before going to NPR, oh, 1 second, permutation. Okay, if you have n objects, if you want to arrange out of R, in how many ways you can do? For the first, you can do in n ways, right? And for the second, you can do n minus 1. Okay. Let me take one example. Suppose you have 5 objects, you want to arrange 3 of them. Then for the first, in how many ways you can do?
5 is
5. For the second?
4.
For the third?
5
3.
for 2. Yeah.
That's all right, because I want to arrange only 3, right?
Yeah.
If you see, can I write 5 into 4 into 3 into 2 into 1, divide by 2 into 1, I multiplied and divide by 2 into 1. Yes or no?
Yes. Yes.
In the numerator part, what I can write? 5 factorial divide by 2 factorial or not?
Yes.
In the denominator part, 5 factorial, can I write 5 minus 3 factorial? Just go
Yes,
with
sir.
this. Okay.
Yes.
Now, I will tell you the general formula. So if I want to arrange R objects out of n, so it's without repetition actually. Without repetition means you can't repeat the object. I will tell you meaning of the repetition also. So it will be n into n minus 1. For R, it will be n minus R minus 1 actually. Okay. You can see here. What is this? This is 5 into 5 minus 1 into 5 minus 2, right? Which is 2 means 5 minus 3 minus 1, right? So if you solve this formula, right, if you multiply it by the appropriate term and divide by appropriate, you will get n factorial divide by n minus r factorial, which is formula of NPR. Okay, like this. So this is something 5p3. Okay, is this fine? Some sort of idea? Okay, so this is the formula of NPR. So in NPR, so why I told you order matters, because if you are going to arrange something, right? So for that particular arrangement, there will be some order, right? Yes or no?
Yes.
So here I told you without repetition. What is the meaning of with repetition? Means suppose you have 10 digit, let's say 0 to 9. Okay, you want to make a password of 4 digit, and you can, okay, first of all, you cannot repeat the digit. Then first place, what is the total number of ways I can choose? Any of the 10 digit, right?
Yes.
For the second place, I can choose any of the
9.
then 8, then
8,
7, which is
7.
same as 10p4. But if I will say repetition is allowed, means I can repeat the digits. See, if I want to create the password, condition is I can make the password like 0000. That means for the first place, what is the total number of ways? 10,
10.
right?
Second
For
also
second,
10.
then
Third also
10,
10.
then
Yeah,
10.
10.
Understood? So this is the for repetition, it will be n raised power r. Is this clear? Some sort of idea?
Yeah.
Okay, yeah. So let me erase these all things. Why I'm erasing? Because we have to solve the particular problem. Okay. Okay, I'm just hoping you people are getting. If you are not getting, just stop me at that, and you can ask the doubt. Okay. So let me tell you the combination formula as well. Then we'll move ahead. Okay. Just a minute. Let me uh, erase this all things quickly. Well, okay. So in permutation, I told you, right? I told you order matters, right? And in combination, order doesn't matter. Okay. Okay, I will come to that point. Okay, just solve this question. Okay, just solve this question. I will come to that point. No worries. We will discuss that question. Just try to solve this question. I will let you know. I mean, I will explain the permutation and combination later. Permutation, hopefully you got. Let's do this things with the counting principle, and then we'll move ahead. Okay, you have to just think the what will be the number appropriate ways. Okay. Just for 5 dice, a little bit hint, for 5 dice, just make a 5 places, and then you can think. So here condition is third and fifth die will turn up a 6 or 1. Okay, so you have to think for third. There is a condition for third and fifth die, and there is not not a single condition for other die. Okay, so by using the counting principle, right, like sort and pant idea, you can simply go with that idea. Just try and let me know in 2 minutes, 3 minutes whether you are getting or not. Anyone, did you get the answer?
Sir, I got 864.
Okay, I'm hoping you didn't see the answer.
No, no, I didn't.
Okay, no worries. I'm just doing jokes about. Okay. Okay, so what about others? Are you trying or should we discuss? If you're trying, then we can wait. We don't have. Okay, I think Hari, you got the answer, right? 864.
No, no, I'm doing it.
Okay. Who got the answer? Can you please?
Sir, it was me, Kaustubh.
Okay, Kaustubh.
Uh-huh.
Okay, so can you tell me what was your approach?
So it was basically 5 dices. So
Well,
like 5 places.
okay. Yeah,
First die can be anything. So it can have 6 possible
correct.
play.
Okay, understood your
Uh-huh.
approach. Okay. Okay, so if you roll any die, right, what is the possible outcomes you can get? You can get 1, you can get 2, you can get 3, you can get 4, you can get 5, and you can get. So total 6 outcomes, right? You can get. So this is the possible outcomes if you are rolling a die. So now it is talking about 5 dice are rolled simultaneously. Let's make for the first die, then second die, then third die, then fourth die, then fifth die. So what is the condition? For the third and fifth die, what is the condition? It can turn up a 6 or 1, right? Then for the third and for the fifth, there is only 2 possibility. Yes or no?
Yes.
Right? Are you getting what I'm trying to say? So for third and fifth, if you see, there is only 2 possibilities. It can 6 or it can 1. So there is only 2 ways, right? Yes or no? And rest, for the first day, it can any of the 6 outcome can be there, and for the second, any of the 6 outcome can be there. For third, it was 2, and for fourth, again any of the 6, and then if you multiply it, right, you will get the 864. 864 is the correct answer. Okay, so is this clear? Some are you did you get the idea? You just be able to think about the statement of the question, right? Well, fine. Any doubt? No? Yes?
Yes.
I mean, clear or doubt? Yes. Yes.
No, it's clear.
Okay. 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 Now, just think like this. So there is a difference in this question. Little bit difference. Okay. Actually, so question is saying. Oh, sorry. Question is 5 dice are rolled simultaneously. In how many ways the outcomes will either the third die or fifth die will turn up a 6? See, here there is a little bit difference. Initially, we talked about third and fifth. Now here I'm talking about either third will turn up 6 or 1 or fifth will turn up 6 or 1. Okay. So if you want to try, then I will give you some 4 to 5 minutes, or else I can discuss. What's your preference? Want to try?
Yes, sir, we will try it.
Okay, okay, sure, sir. Go ahead, please. Yeah.
Sir, can you explain the last problem once more?
216. Is it 216?
216. We'll see what is the answer.
Okay.
Yeah. What about others? Anyone? Did you get the answer or?
So, sir, I got 5184.
5184. Anybody else? Okay, let me solve it, because anyway we have to cover some. There is this is the third question. Okay, let me. So here you have to think about cases. I mean, why cases? Because if you see, there is statement is about either the third or the fifth die, right? So what will be the cases, right? So let's discuss like this. So case one will be like this. See, I'm talking about either the third or fifth die turn up. So what will be the case? Suppose I'm saying the third die, right, turn up a 6, correct? It can be possible or not, correct? If the third die is turn up the 6, then what is the possible ways? Tell me. Anyway, your total 5 dice, right? Then for the first die, what is the total ways?
6.
What about second die?
6.
What about third die?
1.
1, correct? Because I'm just taking 6. What about fourth?
Yeah.
What about fifth? Again 6, right? This is 6 raised to power 4. Yes or no?
Yeah. Yeah.
Okay. Now, what can be the next case?
For
See,
the
the
one.
third die, correct? This is turn up a 1. Yes or no?
Yeah.
If this is the turn up 1, that is first die, second die, third die, fourth die, fifth die. Again, for the first die, any of the 6 outcome can be there, because we have the condition for the third die only. So for third, there is only one way. Then for the second, again 6. For the fourth, again 6. For the fifth, again 6. Which is again 6 plus 4.
Yes.
Yes or no? Then if you see another case, same for the, you have to apply for the fifth die, right? The fifth die, turn up a 6. Yes or no? Then again, what will this is first die, second die, third die, fourth die, fifth die. So for the fifth die, we have the condition, which is 1. Rest 6. Yes or no?
Yes.
Again 6 raised power 4. Are you getting? Rest case 4 will be the fifth die, turn up a 1. Well, then again 1. Then for fourth, I mean for rest of the die, it will be 6, right? So it will be 6 plus 4.
But
Hmm?
yeah.
Yeah, go ahead.
No, that's fine.
So what will the total number of ways? You can see I have total 4, right? 4 cases. I don't think there is any other cases left out. So total ways will be, right? So 6 raised power 4 plus 6 raised power 4 plus 6 raised power 4 plus 6 raised power, which is nothing but 4 into 6 raised power 4, right? Now is this fine?
Okay.
Yeah. You got the idea, right? See, the only thing what you have to do, see, idea is the same. If you know it's a and, you have to apply the multiplication. If it's or, you will do the plus sign. The only thing is you have to think whether any cases is left out, or whether we have considered all the cases or not. Okay. The condition. Okay. Similar cases. Yes.
Can you explain for and in the die? Yes.
Yet and there is a and question, right? Third and fifth die will turn up a 6 or 1.
Yes.
Okay. There was and question. Okay. The second one was the and question.
So can you explain this one?
Okay, so what I'm asking here, saying the third and fifth die will turn up a 6. So we know for third, and fifth is already fixed, 6 or 1, correct? Either it can 6 or 1. So for third and fifth, we will be having only 2 ways, right? Either 6 can
Yes,
occur,
sir.
either 1 can occur. Either 6 can occur, either 1 can occur, right? But for the first die, any of the 6 outcome can be there. For the second die, any of the 6 outcome. Same for the... sorry. Okay. So same for the fourth die. Okay. Fine.
Yes.
Okay. Yeah. The similar is, similar concept you have to see here. The only thing the question is little bit different. Context is different, but concept is the you have to see. Question is how many 3-letter words? First of all, you have to see. I'm talking about 3-letter words. Okay, with or without meaning, we don't no need to worry about without. Can be formed using the letters of the word vertigo without repetition. I mean, we can't repeat the word such that the alphabet I is the one of the alphabet in each of the words form. So just think which what is the condition and let me know.
Sir, is it 126?
I don't know the answer. We can discuss actually. Okay, 126, right? I mean, you got 126. What about others? Okay, whenever you will feel you are not able to approach, just do let me know, right? We can proceed because we have to discuss some more question also.
I got 90.
90. Okay, let's see. You got 90.
I'm also getting 126.
Sorry, 81.
126.
126. Okay, there is 2 vote for 126. Let's see which one is the correct. Even I don't know. We'll see. We'll solve it and we'll see. What about others? Anyone? Should we proceed? Shall we? Okay. Yes, no? Any? Okay, yeah. Okay, yeah, thanks. If you want to stop me, like you can simply say, "I'm trying. Can we wait for some?" That's also fine. So let's see what's the main focus idea. So there is 7 words, right? Vertigo. Condition is, see, for these 3 words, right? We have to take first of all, we have to make a word of 3 letters. But for this condition is I is the one of the alphabet. So see, there is 3 conditions. I can be here, correct? Yes or no? I can be here, or else I can be here, right? These are the possibility, correct? In 3-letter word, these are the only 3 possibility, correct?
Yeah,
Yes or
three
no?
possibility.
Right,
Yeah.
right. If suppose I is here, then in how many ways you can fill this position?
Is two is like it's 7p2.
No, don't go with 7p2. Just
Okay.
a number
Okay.
of ways. In how many ways you can fill? And 7p2 is the wrong. I will tell you why.
Okay.
If I is already used, tell me for the second place, what is the number of letters you have left?
6.
6, right?
Yeah.
It will be 6, correct? For the this place,
Will be 5.
5. So you whatever you're telling, right? 7p2, it's not 7p2, it should be 6p2 actually.
6p2. Yeah.
Okay? Now, what about this case? Again, I is already used. That means what is the remaining letter? I can use any of the 6, right?
6. And
Then
5.
here any of the 5. Then any of the 6 and any of the 5. Since our I is already fixed, right? So what is the number of ways here? Again 6p2. Here again 6p2, right? 6p2 means it's nothing but 30. Yes or no? So 90
Yes.
is the actually correct answer. So because what is the, you have to add this case plus this case and plus this case. So you will get 3 into 6p2, which is nothing but 3 into 6 into 5, which is nothing but 90. Is this clear? Yeah, 3 into 6p2 is the correct answer. Is this fine? Did you get the idea, right? We have to just focus on the statement, right? And just try to think what are the possible cases can be there. Okay.
So in the same example, if they ask about repeating the value, then it will be 7p2.
Sorry. Could you repeat? I was on a call.
If in the same question they ask that we can repeat the letters,
Yes.
then it will be 7p2.
No. Yes. Then it will 7p2. Or else, see, no. If okay, there will be clarification in the word, because suppose I'm saying I can use I only once. Okay. Then I can repeat others. Then it will be 6 into 6. Okay. If you'll repeat, are you getting my idea? If I am saying
Okay.
alphabet I can use only once, and rest later I can repeat. That means it will be 6, and this 5 again it will be 6.
Okay.
Understood? Okay. So there is now the same thing. Yeah, I think same question is there. This your idea come up into the question. Just solve it. Then I'm hoping you people will get the correct answer. Now you see, I use exactly once each of the words form. Now eyes you can use only once, but rest you can repeat.
Yeah, so it will be like 6 into 6, 36, and 36 into 3.
(36 into)
For the 3 times, yes.
Yeah, 36 into 3.
36 into, yeah. Okay.
Yeah.
36, okay. Because you can simply say, what is the question? See, sometimes what people make mistake, they are just randomly, blindly using the 3p2, 3c2. Don't go with like that. Just take a minute and think what are the possible cases can be there. So if you see, I can use I exactly once. Means I can use I exactly once. It can be at the first place, can be a second place, and it can be at the third place, place. But rest later I can repeat. That means for here I can use any of the 6 and any of the 6. That means 36.
36.
Then 6 into I means here I can use only one way, right? Then again it's a total 36. Then 6 into 6. Then it's again 36. So total will be 3 into 36. Okay, which is
36.
108, right?
100. Yeah, 108.
108. Okay. Yeah, 3 into 6 square is the correct answer. Okay. Now, let's do this question. Just tell me for this question. Okay. Okay, so one idea is, okay, let me explain something. Maybe after that you can apply the concept here. If, see, so far we have seen some distinct letter, right? Suppose I'm saying I have a word, let's say data, DATA, right? I want to rearrange this letter. In how many ways we can do? Okay, first of all, if you have 4-letter word, let's say cow, COW, in how many ways you can rearrange? I can rearrange in 3 factorial ways, right?
Yes.
Yes or no? If you have data, in how many ways you can arrange? First of all, you can arrange, let's say D, let's say make it A1 and A2 for differentiating, right? It can be DA2, TA1 or DA1, TA2, right? Or let's say TA1, DA2 and TA2, DA1, something like that. Yes or no? But at the end, if you see, this is the same as data itself, right? This is same as data itself. This is same as TADA, right? Yes or no? So what is this? These two cases you will going to count as a one case, right? Yes or no? So what will the number of ways? First of all, to arrange all these, suppose these all are different. In how many I can do? I can do in 4 factorial ways, right? But out of them, 2 are remaining. 2 are the same, right? If two by seeing this idea, so what I have to divide? If you see, these are the total 4, but I will count this as a 1, right? One word. Yes or no? So I have to divide with 2 factorial. So this 2 factorial for not these two factorial, because 2 of them are repeating. Understood? Okay. So for example, let me take another word. Let's say statistics. How many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in how many, first of all, just assume all are different. Then in how many you can do? You can do in 10 factorial. But
yes,
you have to see what are the repeaters. If you see S is repeating 3 times, T is repeating 3 times, and I is repeating 2 times. That's all, right? Yes. So we have to divide with 3 factorial into 3 factorial into 2 factorial. That's all. Is this fine? Yes. Okay. So by using this concept, please solve this question. Okay. Okay, if you're getting confusion, right, just ignore this red statement. Okay, as of now, then we'll move to the ahead. In how many ways you can arrange the chocolates? Just tell me the answer for that, and then I will move to that part.
Three ways, right?
Just think how 3 ways?
4, 2, 2, 2, 2, 4, and 2, 4, 2.
No, what I told you for data, right? For if I want to arrange this, right, letters of this word, first of all,
yes, sorry.
Okay. I think it's a 5 factorial. No, okay, just think little bit. I think. Okay, rather than assuming randomly.
8 factorial divided by 4 factorial into 2 factorial into 2 factorial.
Yes, yeah. Correct. Okay, if for example, right, if all are different, right, they can you can simply say 8 factorial. But question is, if you see, I have 4 dark chocolate, right? Let's say D1, D2, D3, D4, right? And 2 are milk, M1, M2, 2 are white. Let's say W1, W2. So if you see, right, so these are the repeatings, right? Correct? Something. So okay. So in how many ways you can arrange in total? I can arrange if okay. If I'm going to remove this, if I, in how many ways I can arrange the chocolates? Let's say first arrange the chocolates. Number of ways he can arrange the chocolates. Well, so for this, right? So in how many ways I can arrange? I can arrange all in 8 factorial ways, right?
8 factorial.
Divide by 4 are same. 4 factorial into 2 factorial into 2 factorial. But now let me remove the red part. If you see the second case, number of ways he can arrange when all the dark chocolates are to be placed together, right? Now tell me, if I'm saying, okay, if you see, what are the dark chocolates? There are 4 dark chocolates, right? D1, D2, D3, D4. Then 2 are milk. Let's say M1, M2. Then 2 are white. Let's say W1, W2. So what I'm saying, in the question, it is clearly mentioned all the dark chocolates are placed together. If I'm going to place this as a together always, right? So this will be a single entity or not?
Yes.
Right? And this will be some 4 different entity. Yes or no?
Yes.
So what is the total different entity?
5.
5 factorial, right? Correct? Yes or no? Out of these 5 factorial, 2 are of the same. Yes or no? 1, 2, 1, 2. Well, so this will be single quantity because this is something I'm going to place together. Is this fine?
Yes.
Okay. So that this yeah, this is the answer. Okay. Now, now here you have to think. Next question is, I mean, information is the same, just a little difference. If no 2 milk chocolates are to be placed together. So, okay, first of all, tell me when 2 milk chocolates are to be placed together. Just tell me the number of ways. If you want to find no milk 2 chocolates, so what we can do? We can, okay, tell me which approach you will try to do or apply.
Same as it used to be 7 factorial, right?
No, 7 factorial is okay. I mean, to find the no 2 milk chocolates are to be placed together. Can I find something like that? Total ways minus when 2 milk chocolates are together, right? If I will subtract this, I will find when no 2 milk chocolates are to be placed together. Yes or no?
Yes.
Correct? Yes. So first of all, you have to find when 2 milk chocolates, right, are to be placed together. If this is the case, what is the number of ways? So if you see,
7.
yeah, this will be some 4 different, right? D1, D2, D3, D4.
Yeah.
But this is
Milk
something
one will be
single
1.
quantity, right?
Yes.
Yeah. So what is the total different? 1, 2, 3, 4, 5, 6, 7. So what will be the 7 factorial divide by? Divide by?
1 into 4 into...
Yeah. 4 factorial into 2 factorial. Why 4? Because these are the same kind of things, right? These are the, again, same kind of. Yes or no?
Yes.
Right? Now, you told me what is the total number of ways? Total ways?
8 factorial
8 factorial, and out of
by
8, 4 were
4
same
factorial.
kind, right?
Yeah, 2
Into,
factorial and 2 factorial.
well, very good. So I need for no 2 milk chocolate. So correct way will be this total weighs, right? Into 2 factorial into 2 factorial minus
Minus
7 factorial 4 factorial into 2 factorial. Okay, you have to just solve this, right? So this will be the correct answer. You have to just solve this. You have to apply this solves. Okay, all right. Okay, idea is clear to all of you?
Yes.
Okay, now just read this question, question number 8, and tell me the answer. Just think. I think this is the similar questions we have done. If you see the where we have to place I, yes or no?
Yes. Yes.
Yes or no, right?
Yes.
Okay, that is the similar case. Where is, I think answer will be the same.
Yes. 90.
Okay, well. Okay, let's see. So your question is, if you see the same kind of question we have done, I have some 7 people, right? Out of them, out of 7 people, here I will use the permutation. I will tell you why permutation, or you can go with the counting principle also, because here order matters, right? What I mean by order matters, for example, let's say there are 3 person, P1, P2 and P3, right? If person 1 is the president, person 2 is the vice president, and person 3 is the secretary, right? And if suppose I'm saying person 1 is the vice president, person 2 is the secretary, and person 3 is the president, right? Then this order is different from this order, right? Okay, is this or not? Because in the first one, person 1 is the president, while in the second one, person 1 is the vice president. So this is the meaning of order matters. Okay, I will come to the order doesn't matter also. Let me tell you. So in this scenario, I will go for the permutation. Okay, what do you mean by, then I will write here what is the total way? 7p3. I will say, I'm talking about in general. I'm not going for this question itself. For example, what do you mean by the combination? I will tell you. Combination means order doesn't matter. Okay, order doesn't matter. I'm going with the only for the selection part. For example, I'm saying I have 7 people in a room. Okay, and I'm going to select 3 people. I have to select 3 people. That's all. I stopped. Then in how many ways you can do? If you want to select 3 people, suppose you have selected person 1, P1 first, P2 second, then 3 at the last, or P3, then P1, then P2, or P1, P3, P2. Anyway, if I'm not talking about order, all these 3 are the same or not? You selected anyway these these three people, yes or no? These 3%. If I'm not talking about any particular order after selecting. Are you getting my idea here?
Yes.
Okay. So what I'm talking, see here initially in the previous one, see I have selected 3 people, but I'm going to give some order, some ranking, right? So here order matters. While if you selected P1 first or P1 second or P1 third or something like that, is there any order matters? No. All are the cases is the same, right? Anyway you have selected these 3%. That's all. Yes or no? Not any order. Correct? So in this scenario, I will go for the combination. Means here I'm going to do 7C3. What is the formula? Formula is nothing but in general n choose r is n factorial divided by r factorial into n minus r factorial. While in case of NPR, what is the formula? N factorial divided by n minus r factorial. Now, okay, if you see the formula little bit carefully, right? In this formula, n factorial, r factorial, n minus r factorial. Now, what I am doing here? I'm just selecting these 3 people, right? Yes or no? If I have selected these, suppose r people, if I will in okay, I have selected these 3 people first of all. In how many ways I can do? I can do in 7C3, right? Now, if I want to arrange these people, for example, in these positions, vice president, secretary, and president, in how many ways I can arrange? If you have 3%, in how many ways arrange those 3%? At a 3,
3, 2, 1.
No, not 3, 2, 1. 3 into 2 into 1, you are talking, say?
Yeah.
Yeah, that means 3 factorial. Okay, so if you see here carefully, right? So what is this? 7C3 into 3 factorial is what? This is same as 7P3. So what if you focus here, what I'm doing, this 7P3 I got when I had order, right? This 7C3 means what? I'm just selecting the people, right? Selecting 3 people. Now, if you multiply it by 3 factorial, that means you are doing the arrangement of these 3 people, right? At some place, president, vice president, secretary, right? So that means what? This P3 you got when you applied the arrangement concept, means you have given some order. If you are not going to give order, this will be only 7C3. Is the rough idea is clear?
Yes.
Okay, clear to all? Okay, yes, no? So combination will be used only for the when we are not worrying about the order, but permutation we will be used when our concern is about order, right? In any kind of order, any arrangement and all. Okay, so let's focus on this question itself. Okay, then we'll move to the okay. So this question is very similar. I think approximately similar the question which we have done for the I1, right, where the word I was fixed. Okay, let's try to think like this in the similar way itself. Okay, so what is the question saying? Question is saying I have position of 3, right? President, vice president, and secretary. Then president, vice president, and secretary. President and vice president, secretary. I feel because it says these 3 positions, if the president position, okay, if I'm ignoring this statement, then what will be the answer? In how many ways you can fill these 3 positions? If we are going to ignore the last condition, in how many ways you can fill these positions?
7 factorial.
Only 7 factorial. Just think.
Yeah, 7 factorial. Yeah.
Just think. Just your 3. 7
So
factorial.
7.
One second. I think you didn't get the idea, right? For 5 factorial means what? If you have 5 books and you have 5 places, right?
Yeah, it's
Then,
a 7.
Okay. Tell me.
P3.
1 second. Yeah, that's correct. If you have 5 books, you want to arrange at the 5 places, then it will be 5 into 4 into 3 into 2 into 1, that is the 5 factorial, right? If you have 5 book, if you want to arrange at 5 places, that means you can arrange for 5, and second place you will be having 4, it will be 3,
Yeah.
which is nothing but 5p3, right?
Hmm.
Okay, so if I will if you ignore this rate, then you can do in 7p3, because just think, okay, just think like this. You have position of president, you have position of vice president, you have position of secretary. In how many ways you can fill this? 7 ways. In how many ways you can fill this? 6 ways.
6
In how
ways
many?
and 5 ways.
5 ways. You don't have 7 different positions, right? So that's why this
Yeah.
is 7p3. Okay, now forget about this case, let's focus our main question. We are actually every time. Okay, so this is saying, if one position filled by women, if one position is filled by women, so what are the total number of ways I can fill the position by women? Suppose there is one woman, right? And there is another one woman, and there is one woman, right?
Yes.
Okay, then what about this? I can take any of the,
6
then
and
5,
5.
then 6,
6,
and then
5.
5, then 6 and 5, right?
This
So it will
90.
be 3 into 6 p2, right? Or 3 into 30, which is 90.
Yes.
Or you can think like that, we have total 3 places, right? And I have 3
Yeah.
women, correct? So these 3 women can take any of the 3 places,
Correct.
that is 3, correct, into remaining 2, it will be 6 into 5, again 90. Understood? Okay, let's move to the next part. Question is the same. In how many ways can the 3 persons be selected? To fill this person, at least one of the selected person is a man. Okay, so here you have to think about the person is a man. So here I'm interested in the number of selection. Okay.
So here it means like repetition is allowed, right?
No. At least one way means you want to select 3 person, right? Then it will be 1 man can be there, then 2 men can be there, then 3 men can be there. Okay. And here,
I think this will be again like a similar question to last time. Only there the post was mentioned. Here the post is not mentioned, but it is mandatory to have 1 man at least.
correct. If post is not mentioned, that means what?
The order is not there.
Order is not there. That means I can use the
Combination.
very good. Yeah, that's you got the idea. Okay. So here post is not mentioned. Initially post was mentioned, right? Here I'm our objective is only about the selection of the people, right? Okay. Okay, should I do, or is it you are trying? Should I do, or if you are trying, then we can. Okay, Siddharth is saying I should. Okay, let me proceed, because we have to do some 10 more questions. Okay, it's already about 8. Okay, let's do. Okay, so can you tell me, first of all, if see, at least one means what? We have to choose one man, right? Then
Yes.
two men, correct? Then all are men, correct? Or can I say like this? If I want at least one, that can I say, if I will subtract total minus no man, then that will again give me at least one, right? That is meaning of at least one. Yes or no? Are you getting?
Yes. Total
Correct?
minus no man.
Yeah.
Yes.
If I'm saying, see, at least one means what? There should be one man, at least one. One of the selected person is man. One of the selected person is man. That means what? I will simply say total ways, right? Minus no man, right? Now, first of all, what is the total ways in which I can select 3 people? Tell me. In how many ways? So it's, what should I write?
So,
See, total are 7 people, right? I have to choose
yes.
any of the 3. In how many ways I can do? I can do 7 choose 3, right? And
3.
formula of this is 7 factorial divide by 3 factorial into 7 minus 3,
7
which is
minus 3, 4. Yeah.
4. So if you see that this above 7 factorial, I can write this 7 factorial as 7 into 6 into 5 into 4 factorial, or not, right?
Yes.
And this 3 factorial is 3 into 2 into 1 into 4 factorial.
4
So 4
factorial.
will get cancelled out. This 3 to 6
Yes.
will get
35.
cancelled out. I will be having 35.
35.
And what is number of ways I can select no man? So no man means what? All are women?
Yeah.
Yes or no? All are women means what? What is the total number of women? 3.
3.
That means 3C3, right?
Yes.
Which is 1.
This is
This 3 factorial, 3 factorial into 0 factorial, and 0 factorial we are taking by convention is 1. We are not going to mathematics here. So 1. So total, I mean, the required ways will be 35 minus 1, which is nothing but 34. Okay, is this clear?
yes.
Okay, let's move to the next part. Yes. So now here question is, at a party there are 2 groups. One group consists of 4 speaking members, speaking English speaking members and their president, while the others consist of 4 French speaking members and their president. In how many ways can they be seated in a row such that president of the both groups are seated next to each other? So I think this is a very similar to the question. Okay, first of all, if question is just remove this one, then in how many ways you can do? Tell me. In a row of, let's say I'm saying 10 seats, then in how many ways you can do?
So it will be
10 factorial.
10 factorial, right? Because you have total 10 people, 4 English and 1 president, 5, then 4 French speaking, then their president, 5, 5, 5, 10, and you have 10 seats. You can simply do 10 for 10, 10 into 9 into 8 into up to 1, 10 factorial, right? Okay. Now this is very similar to chocolate one, when you are taking something at a together. So by using the same concept, let me know. Okay. I'm not saying exactly same to the chocolate one, but yeah, concept is a little bit, I mean, something similar to. Okay, and just we'll be back in 2 minutes. Just try it. Okay, so did you get the answer? Yes, no?
Hello.
Yes, yes, yes. Of
Yes.
course.
So I got 9 factorial by 4 factorial into 4 factorial.
Okay, I will tell you the
I think it
difference.
is 9 factorial.
Okay, 9 factorial. Okay, 9 factorial. Those who answer only 9 factorial, they are somewhat correct. Not divided by 4 factorial and 4 factorial. Why? Because if here you are talking about person, right? Person cannot be identical, right? See,
Yes, yes.
okay. If I have data, right? I can do 4 factorial divided by 2 factorial. Why? A looks like same, but it's not about person, right? Okay. That will not be true under person. 9 is somewhat clear, correct, but there is one more thing. Okay, because here saying president of both groups are seated to next to each other. Okay, for English people, right, means so there are 4 English people, right, and one president, correct, and then 4 French speaking people and one their president. So here they are saying these two president, right? Let me denote as PE, president of English, and president of French. So what they are saying, this PE and president of, they are going to sit together, right? Then remaining E1, E2, E3, E4 means 4 English, then F1, F2, F3, F4. So this will I can consider as a single quantity or not? Because they are going to sit together, right? Yes or no? So what is the total distinct entry? 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is the, I can arrange in 9 factorial ways. But
Yeah.
I can arrange among themselves also, right? It's not about P and PF is fixed, right? I can do PF, then PE, right? In how many is arrange these two people? Are you getting my idea, right? I can rearrange among themselves, right? So I can arrange in those two people in how many ways?
2
2
2
factorial.
years.
So this is the correct answer, 2 factorial into 9 factorial. Is this fine? Okay. Now let's, the question is same. Now it's talking about around a round table. Previously it was the in a row. Okay, forget about this case and let me know. Okay, I will give you one idea. I think Amanu, can you mute? There is background noise from your end. Okay, thank you. Whenever you doubt, you can unmute. Not a problem. Okay, if I'm erasing this line, okay, so just let me give you idea. If you want to arrange something, let's say 4 thing in a row, you can arrange in 4 factorial way, right? Let's say A, B, and C. And suppose if you want to arrange in a circular manner, okay, so let's say A is here, B is here, C is here, D is here, right? This is something you can do in 4 factorial ways, right? Correct. If you want to arrange linear, but if you want to arrange a circular order, round table, but I can go from here also, right? A, B, C, and D or not? Yes or no? Arrangement anyway, I will get A, B, C, D. The same thing, you can start from here itself. A, B, C, and D. Yes or no? Are you getting my idea?
Yes, sir.
And you can simply start from here also. A, B, C, and D. Yes or no? So in all cases, you can simply say you are going to get this same arrangement, right? If I'm talking about a round table or circular table, yes or no? Here it's not about linear only. It's about linear, then it's a 4 factorial. But around circular, suppose you are here, you can simply say A, B, C, D. If you are here, you can simply say A, you can simply see A, B, C, and D. Sorry. If you are here, you can simply say A, B, C, and D, right? So you can simply see what are the common cases? How many common cases are there? 1, 2, 3, 4, 5. How many? 4, right?
I mean 4 overall 4, yeah.
Overall 4, right? So
Yes.
if you see this formula, what is the, can I write this 4 into 3 factorial divided by 4? This will get cancel out. I will be having 3 factorial. This is nothing but 4 minus 1 factorial. Why I have written like this? Because if you have n n things, you have to arrange around a circular table, right? Okay. And clockwise and anti-clockwise are different. Okay. This is, then there is total n minus 1 factorial ways. Okay. Because you can do n factorial divided by n. So what I'm saying, clockwise and anti-clockwise are different. Okay. So what do you mean by clockwise, anti-clockwise different? Means if you are going like this, right, clockwise, you will see the different arrangement. If you are going anti-clockwise, you will see the different arrangement. Then it will be n minus 1 factorial. If clockwise and anti-clockwise are same, okay. So clockwise, anti-clockwise are same means what? This arrangement or this way arrangement, if you are saying the same, again I can divide by 2 factorial or not, right? So basically this is something you can simply say mirror image. If I'm saying clockwise and anti-clockwise are same, that means mirror images are same, so I can divide by 2. Okay, is this clear? Okay, so if it's about person, so clockwise, anti-clockwise wise will not be same, but if it's about something, you can simply say check the necklace, right? If you see necklace, circular necklace, right? If you see the mirror image of necklace, okay, then it will be same. It will look like same or not? Yes or no? Then it will be, you can apply the circular permutation concept when clockwise, anti-clockwise are same. Okay. So by using the same concept, just tell me, if you see here, if I'm going to remove this statement, okay, then what will the answer? What is the total number of people? 10, right?
And
Then in how many ways you can arrange these 10 people around a circular table?
N minus 1.
So it will be
Factorial 9.
9 factorial, right? Now there is one condition. Let's go with this condition itself. Okay. Now this 9 factorial is okay. Let's go with this condition. So what they are saying, this president of both groups are seated next to each other, right? So this is a circular table, right? Suppose there are some different people. Let's say E1, F1 is there, then F2 is there, some E2 is there, some E3 is there, then F3. F3 means French speaking person 3. Then F4 is there, then E4 there. So what they are saying, president, let's say P1 and P2, they are going to sit together, right? That is the meaning. Now tell me, what are the different quantities? So this will be considered as a single quantity. What are the distinct elements? 1, 2, 3, 4, 5, 6, 7, 8, and 9, right?
9.
So in how many ways you can arrange this 9?
So it will be 8 factorial.
9 minus 1 factorial, which is 8 factorial. But I can...
Then this 2 another time.
Correct. I can arrange among themselves also, right? Okay.
Yes.
I can do in 2 factorial. This will be the answer. Is this clear? So what is the meaning of...
why it is 9 minus 1 actually?
Well, okay, okay, the previous example I took, did you get that n minus 1 factorial?
Yes, yes.
The same thing, right? Here total 9 different people, right? Because they are going to sit together. So I will consider as a single entity. Okay. See, if this is not condition, right? Suppose they are not going to sit together. I have 10 different people and I have to arrange around a circular table. I will do in 10 minus 1 factorial, that is 9 factorial ways. Okay. But condition is they are going to sit together. If they are going to sit together, that means what? This P1 and P2 will be single quantity, right? So you will be having total 9 different entity, right? So in how many ways you can arrange 9 things? 9 minus 1 factorial, which is 8 factorial. Is this clear?
Yes, sir.
Okay.
Yes.
See, you can simply see uh, in a row, right? In a row, in how many ways you can arrange? 9 factorial, right? Right? This is the case, right? When they are sitting together, but in a row. Yes or no?
Yes.
Correct? But here in the circular manner, okay, what is the thing? Why we are writing? Okay, first of all, you can simply think I can arrange in 9 factorial. But what is the case? This P1 and P2 can be here also, can be here also, can be here also, right? Can be here also, can be here also, can be here also, and can be here also, can be here also. So if you are here, right, then you will see the same arrangement. If you are here, you will see the same arrangement, right? So that's why we are dividing by 9 actually. That's why it's a n minus 1 factorial actually. Here it will be 8 actually. No, 9 itself. Okay, n factorial divided by n. Okay, is this fine? Some idea is clear? Yes, no?
Yes.
Clear?
Yes.
Okay, yeah. So here you can see clockwise and anti-clockwise are different, right? So because it's about person, if you are here, right, if you see this kind of arrangement, right, clockwise, or if you see anti-clockwise, you will get the different arrangement, right? So that's why we are not dividing by 2. If you are going like this, or if you are going like this, and you are seeing the same arrangement, that means you have to divide by 2 again, because in both way I'm able to see the same arrangement. Okay, let's do the next question, which is the something like this. Find the number of ways in which 7 beads can be arranged to form a necklace. Now tell me, this is something we have discussed. Just tell me. I think for this you can simply tell me the direct answer.
So 6.
Only 6.
Yeah. 6 factorial means the n
Why
minus 1.
Okay, n minus 1 factor, right?
Yeah, 7 minus 1.
That is 6 factor, right?
Yes.
Yes.
Okay. When this is n minus factor, we are using when?
In the circular form.
I think
Right?
it is n minus 1 by 2.
Clockwise.
Correct. See here, clockwise and anti-clockwise are different, right?
Yeah.
Right? Yes or no? If you
Yes.
are making a beads, right? I mean necklace with the help of beads, right? So suppose this is a something necklace. Okay, some beads are there. Okay, something like that. If you are here, right? If you see like this, or if you see like this, it will look like same or not? If you see in the mirror image will be same or not?
Yes.
Okay. So to arrange around a circular table, we know it's a n minus 1 factorial, but both way, right? Clockwise and anti-clockwise, it will be same. So I will divide by 2.
Okay.
Okay. So clockwise and anti-clockwise are same. So it will be 7 minus 1 factorial divided by 2, which is 6 factorial divided by 2. Okay. 6 factorial divided by 2. While in the case of person, right? If you about person, right? If you see here, if you go like this, so you can simply say you will get the arrangement E1, F1, F2, and so on at the last P1 and P2, right? But if you go anti-clockwise, what will the arrangement you will get from, if you are here, suppose you are sitting here, you will get E1, P2, P1. So arrangement is different, right? Yes or no? But while in the case of necklace, you will get the same. Understood?
Clear.
Yeah. Okay. Well, now next one is about you have to identify which one is the random experiment. Let me tell you what is the meaning of definition of random experiment.
Sir, for the last one, it is 6 factorial by 2 factorial, right?
No, only 2, not
Okay.
about factorial.
Okay.
2 because you will get the same thing.
Yes, anti and
Yes. Yeah. So what is the random experiment? Suppose you are performing any experiment. Okay. So definition of random experiment means you know the what are the possible outcomes maybe, but you can't predict the outcomes with certainty. I mean, this will be the exact outcome. What is the meaning of certainty? So, for example, suppose you are going to toss a coin. Okay. Suppose you are going to toss a coin. So what are the possible outcomes you can get?
Possible will be like head or
Head or tail, right? But
yes.
can you predict which one will come, either head or tail? You can't predict, right?
Can't.
So that is called something random experiment. Means you know the possible outcomes. Okay, but can't predict with certainty. Okay, did you get? For example, you have a deck of cards. Okay, so there are total 52 cards, right, in a deck. Yes or no? Some spades, some hearts, some diamonds.
Yes.
I'm saying you have to draw a card. Then you know that card maybe spade, maybe heart, diamond, anything. But can you predict which one will come?
No.
No, right? So by using this idea, just tell me which one is the which option should be correct. Which is the random experiment.
All of them.
All of them are, yeah, correct. All of them are correct, because first option is saying it's a selecting a family out of a given group of family. So you know, suppose there is a 10 group of family, you know, if you will select one family can be there, but it's not about which one will be there, you don't know. Same with the card, I took the example. Same, you are rolling a die, right? You know any of the outcome can be 1, 2, 3, 4, 5, 6, but you can't predict with certainty. Yes or no? Okay,
Yes.
so these kind of experiment comes under the random experiment. And there is something called deterministic experiment. We are not going to yesterday, but I will give you that. Deterministic means something, suppose there is some vehicle or some thing is there, right? A thing is there, and you know, due to some within some time, with some velocity, it will be here, right? Something like that. By what time it will be at this place. So this is something with this is called something deterministic. But random is you can't predict the outcome. Here you can predict, right? If you'll fix some time, some distance, and all, then you can predict, yes or no. Okay, but here you can't. Well, so all of the incorrect. Let's come to the probability part. So there is something probability is nothing but, normally we are defining probability as a favorable case. Okay, and divide by total number of cases. Okay, so here you have to think what is the total possible outcomes. Okay, if you are going to, so your question is, if you are going to throw die twice, that means what? Okay, if you are going to throw a die single time, what are the possible outcomes? How many possible outcomes you will get?
6.
6. If you are going to throw 2 dice, then you have to make you can simply make a sample space, right? So sample space is nothing but where a collection of all the possible outcomes actually. Okay, all possible outcomes. So tell me, if you are if you are going to roll 2 die, right, then how many possible outcomes you will get? Just think.
So 6 into 6.
36, right? So basically how 36, it will be basically, it can be 1 1, right? It can be 1 2, it can be 1 3, it can be 1 at the first die, then 4 for the second, then 1 5, then 1 6. Yes or no? Right? Same, 2 1 up to 2 6, then 3 1. Similarly, it will be like this: 4 1 5 1, and then 6 1 up to 6 6. So total is 36 outcomes. Okay, so you can see what is the total case. Total is 36. Okay, what is the favorable? Favorable means what is the objective? So objective is both dice show the same number. So you have to find the total number of ways where both die will show the same number. What are those? What are the those cases?
6 by 36.
6, right?
6.
So
Yes.
same number means what? What are the cases?
1
It can be
1,
1 1, it
2
can be
2,
2 2, it can
3
be
3,
3
4
3, it
4,
can be 4 4, it can be 5 5,
5
it
5,
can be
6
6
6.
6. So here There are 6 favorable cases, so it will be 6 by 36, which is nothing but 1 by 6. Okay, so that is 0.17. So 0.17 is the correct. This is very basic probability thing. Okay, is this all right? Okay, yeah. Let's move to the next question. So this is something. Okay, before this, let me give you one formula that is called addition rule of. Let me addition rule of probability. So what this rule says, if I have two event A and B, then union of those two event I can write as a P of A plus P of B minus probability of A intersection B. Okay. So union means everyone is aware about this union intersection, right? Union means either in A or B, right? And intersection means both. Okay, means let's say suppose this is A, this is B. Okay, so union B means this whole things, and this is A, this is B. So A intersection B means this common region. Okay, so this is A union B, this is A intersection B. Okay, so that is the above one is the formula. Okay, by using that concept, can you solve it, or should I do?
Question is.
Okay, question is this: P of C is given to you, P of A union B is given to you, and A union B union C is 0.6. Then you have to find this one. Okay, okay. Let me give you a hint. If you focus little bit carefully, can this A union B, can I write this as a D? Let A union B as another event D. Then what we will be having? I have P of C as a 0.2, P of D as a 0.5, and I have A union B, I have let as a D. Then D union C as a 0.6, and I have to calculate probability of D intersection C. Yes or no? Correct. Now, can I use this formula now? I have been given this, I have been given this, I have been given this, I have to calculate this one. Okay. So if instead of B, A and A, B and A and B, I have C and D. So I can write C union D, okay, or D union C. Let's go like this, not a problem. So D union C, I will write probability of D plus probability of C minus probability of D intersection C. So what is the D union C? This is 0.6. What is the D? 0.5. What is the point C? 0.2 minus probability of D intersection C. Okay. Now I have to calculate this one. So can I write probability of D intersection C as a, this will be 0.7 minus 0.6, which is nothing but 0.1. So what was the D I took? I took D as A union B. So A union B intersection C is the 0.1. That's all. Is this clear? Yeah, 0.1 is the correct answer. Is this all right? Any doubt?
Yes, could you show the formula once?
Well, yeah. This is called addition rule of probability.
Oh yeah, you can continue.
Okay. Is this all right to everyone? Correct? Yes, no? Is this fine, right?
Right.
Okay. Yeah, this is the something here you can use the combination and all idea of combination, and let me know. Just solve it. If you you can tell me in terms of combination also. That's fine. But let me know what is the answer.
19C3.
19C3 is what? I mean, 90C3 is what? I mean, what is the role of 90C3?
The total.
Total, right? So here you can see, right? See, combination I can use when without replacement is mentioned, right? With replacement, we can't use combination. Okay. So here see, you know, probability is what? Favorable cases divided by total cases, right? So what is the question? question is saying an uncontained 6 white, 4 red and 9 black ball, right? And if 3 balls are drawn at random without replacement, then find the probability that one is of each color. So one is of each color is the, we have to find the probability of one is of each color. This is the favorable case. What is the total case? Means in how many ways I can choose 3 balls out of how many, what is the total balls? 6, 4, 10, 90, right? 19 is the total, correct? So I have to choose 3 balls out of 19. That means I can do 19 choose 3, right? And what is the favorable? Favorable means one is of each color, means one ball should be of white, one should be of red, one should be of black. So that means what? In how many ways you can choose one white ball?
Six you.
6 ways.
6C1, right? Yeah, 6 ways. That is the 6C. 6C1 is the 6C. 6 itself, right? And what about 4? 4C1.
4C1 and
Then
9C.
yeah, why I have taken 1 because it's one is of each color. So you selected total 3. One is white, one is red, and one is black. Is this clear? It's about without replacement. Okay, if it's with repetition, then answer will get changed. Okay. Okay, if it's with repetition, okay, if it's without replacement, with repetition, then what it will be? Tell me. First of all, what is the probability to draw a white ball? It will be 6 by 19. Yes or no?
Yes.
Then
4 by 19.
4 by 19, then 9 by 19.
Yeah.
And what are we doing here? We are doing 6 by 19, then 4 by 18 without replacement, then 9 by 17. But that's not case. We are adding some other cases because see here 6 is what? White, red, blue, right? White, red, blue. See, here we are not worrying about order also, right? If you worrying about order, see here it can be red, blue, white, right? Or red, white, black, correct? So that's why we are using C3. If you solve this case, right? Solve this formula, it will be 6 into 4 into 9. In the denominator, you will get 19 factorial divided by 3 factorial into 16 factorial. So 19, 18 into 17 into 16 will get cancelled out. So this 3 factorial, it will be in the numerator part, right? So what this 3 factorial is there? These all are possible cases. That is the case. Okay. Means, are you getting? See, it can be black, white, red. It can be black, red, white, right? Yes or no? So all possible cases we are taking. So that's why in without replacement, I can directly use the combination. Is this all right? Is this clear, right, or not? Any doubt? Okay. So if you solve this, you will get this 0.22 as the answer. Is this clear, right? Are you getting some idea, some sort of? Right? Okay. Yeah. Let's move to the next question. I mean, this kind of question we have done. If an contains 6 white, 4 red, and 9 black balls, if 3 balls are drawn at random without replacement, find the probability none is of red color. None is of red color. Then means what? Means we don't want to draw red color ball.
So
It will
that
be like
will
61, 4C0, 9C1, right? 9, okay, 6.
First of all, what will be the total case?
Total is 19.
Now, okay, it means total is 19,
Yes.
and total ways to choose 3 balls without replacement. That is 19C3. Yes or no?
Yes.
Correct. What is the favorable case? Favorable case here, I don't want to choose a red color ball, right? That means what? I have 6 white and 9 black balls, right? See, no
6.
red ball means what?
We will not.
That means I will choose, right? I will select 3 balls out of 6 white and 9 black? Yes or no? Right? So that means what? I have to choose 3 balls out of 15, right? Which can be done in 15C3 ways, yes or no? Are you getting the question? Clearly say I don't want to choose a red ball. That means
Yes.
I have
Yes.
to choose 3 balls out of white and 9. So that will be the favorable case. So probability will be 15C3 divided by 19. Is this clear?
Yes.
Yeah, it's a very simple thing. Okay. So if you solve this right, you will get the answer as a 0.47. Well, fine. Okay. Now let's move to the next question, which is says an urn contains 5 blue and 8 red balls. 2 balls are drawn at random without replacement. What is the probability that first ball is red and second ball is blue? It's very clearly mentioned. First is red and second is blue.
Here we do permutation.
Don't go with the formula. See, that's what I'm saying. Don't you memorize the formula, right? Like permutation. Just think. If you're doing permutation, whatever, just tell me what it will be if you want to do permutation. Yeah, you are okay. I'm not saying you are wrong. You can do for total case permutation, but what it will be? So where order is fixed, you can simply do permutation 8P1, 5P1. I'm not denying you are incorrect. I mean, you are wrong, but yeah.
8C1 into 5C1.
Okay. See, why 5C1, C1?
5 blue balls.
So here, okay, no, you will get the same answer. Okay, tell me the probability, exact probability.
Okay. I think it would be 5 plus 8 is 13. It would be 13P2 would be the total.
Okay,
And
well,
possible would be 5C1 plus 8C1.
not plus. Why plus?
Sorry, since it is and it would be multiplication.
Correct. So basically, yeah, correct. So basically, you can go like this. Let's simplify. I'm saying R. I'm denoting R as a. Let's say I'm saying normally we are taking A and B. Suppose I am saying first ball is red. Okay. Well, and I'm saying blue B as a. Suppose I'm denoting second ball is a blue. Okay. So what is the question? Question is saying what is the probability that first ball is red and second ball is a blue? So can I write I'm interested in probability of R and B intersection part? And can I write this? This means what? Okay, there is something you can directly use. So that's called multiplication rule. I will show. So if you see that means what? First is red. What is the probability that red into what is the probability that blue ball given that red is drawn at the first draw or not? Yes or no? Can I say? Well, are you getting? This means what? First ball is red and second ball is blue. Since we are doing without replacement, I'm saying given means red is already drawn. This is sign for given. Okay. So what is the probability for red drawing a red ball?
8 out of 13.
Okay, 8 out of 13. What is the probability that drawing a blue ball given that red is already drawn?
5 out of 12.
5 out of 12. Okay, that is something someone told, right? This is the 13P2 and it should be 8P1 and into 5P1. Well, fine. Right? Yes, no, any thought? Yes or no? It's clear, right? Or any doubt?
Sir, in denominator, why will it be P and not C? 13 P2 and not C2.
Okay, when we are using C,
When
where
we are
we don't worrying
using
about
define
order,
order.
right? Correct? Where we don't worrying about order, yes or no?
Okay.
Here it is mentioned, right? I'm saying first is red, second is blue. If I'm saying I have to draw two balls, one ball is blue and one ball is red, then I can do C2. It can be RB and BR, doesn't matter, right?
So all the arrangements which are possible. This
Correct.
13 P2. Okay.
No. 13 P2 is for order, 13 C2 is for not without order, okay? If you are getting
Okay.
confusion P2 and C2, just go by this form, this one, okay? No need to worry about it. Well,
Okay.
okay. Yeah. So there is two remaining question. Before, for this question, let me introduce, how many of you know conditional probability? Anyone? Yes, no, anything? You can simply,
Studied long back, so forgot.
okay, yeah, no problem. So conditional probability, suppose I have two event A and event B. Well, so I'm saying what is the, suppose I'm interested to know what is the probability that A given B, means what is the probability of occurring A given that B is already occurred. So formula is probability of A intersection B divided by probability of B. From where this formula came, let me try to explain with Venn diagram. Suppose this is A and this one is the B. Okay, suppose this is the B, this is the A. So what I'm saying, B is already occurred. Okay, so B is already occurred means what I'm saying, this B is already occurred. Okay, that means this green shaded region is already occurred. So far, so good. Yes or no? Right? Now, what I'm saying, if B is already occurred, so this is the my new sample space. So this is the my total case. You can simply consider two total case. If B is already occurred, then what is the probability that A will occur? What is the chance for A occurring? If this green region is already happened, then what is the chance of occurring of A? This common region, right?
A intersection B.
Correct? A intersection B. That's why this formula is a probability of A intersection B divided by probability of B. Fine. Okay. So this is called something conditional probability formula. Now, if you will do a little bit manipulation here, means if you multiply probability of B here, I mean I will do probability of A intersection B as probability of B into probability of A given B. So this is called multiplication rule. Okay, this is something called multiplication rule. The same thing we have used here, right? Okay, is this clear? Some ideas, right? This conditional probability and multiplication rule. Yes, no? Is this
Yes.
fine? Yeah, is this fine? Okay, yeah. So let's move to the next question. Okay, so this question says, now in this question, okay, something is, let me let me give you one formula, then you can try to solve this question. Okay, suppose I'm saying this is your sample space. Okay, in this sample space there is two things. Let's say there is this is, so suppose this is E1, this is E2. These are the two events. Okay, and one another event, let's say A is going to occur here. Okay, event A. So question is, if I will ask what is the probability that A will occur? So when A will occur, this region, right? That means probability that, okay, first of all, A will occur means what? If I will say A intersection E1, can I say or not? If this will occur and this green region will occur, right? Or union of A intersection E2, then I will say A will occur or not. Are you getting? Only then total A will occur. Are you getting? See, I have two events A and B. Then A union B means this whole shaded region. The same thing here, including union of blue and green. Okay. So I will say A has already occurred. Yes or no? Correct?
Yes.
So if you apply the probability, so probability of A will be what? Probability of A intersection E1. This is the union part. It will be plus probability of A intersection E2. Okay. So now tell me, if you will apply the, okay, here you have seen the multiplication rule, means probability of A intersection B is nothing but probability of B into probability of A given B. Okay. So can I use this formula? Then can I write here probability of, okay, just think. I'm saying A intersection E1 means what? I'm saying E1 is already occurred into probability that A will occur in the given E1. Yes or no? See, when A will occur, this blue region, I'm saying E1 is already occurred. What is the probability of E1? Within that, find, given that E1 is there, and what is the probability of A? Fine. Or probability that E2 is there into probability of A given E2 by this multiplication rule. Can I write this or not? Yes or no? Right? Are you getting some sort of idea here? If you are not,
Yes.
if you are getting confusion, do let me know. Okay. So basically, this is called something a law of total probability in probability world actually. Now, by using this same information, can you solve this question, or do I solve it? Should I solve it?
Now, one question.
Yes.
As per the addition of probability rule in the
Hmm.
second line, right? Uh, why
Uh,
didn't you put?
Intersection part. Okay, I
Yeah,
will tell you.
since it
Okay,
is a
see.
zero, you didn't put it.
Yeah, it's a zero because, okay, that is zero means actually here you can simply see this E1, and basically see that is something. Okay, let me tell you that example itself. That's the very nice question itself. Actually, see, whenever I will say A and B are disjoint event, okay. So disjoint means there is intersection between these two is phi, means there is nothing common. So probability of A intersection B will be, so probability of an impossible event is 0. So this will be 0. That's why I have excluded the intersection part. Okay. So here in this case, right, so these two will be considered as a, normally as per the concept we are considering as a disjoint event, means they are not, means this is different, this is the different, there is nothing common between these two, right? You can simply see there is nothing common, right? Okay, that's why
Yeah,
intersection part we haven't included. Now is it
yeah,
clear? Well,
yeah. I understand that.
okay,
But question is like with that you cannot make the law for total probability, right? Because there may be
correct.
in this example, yes.
Yes, in this example, so actually that, okay, whenever you will apply law of total probability and Bayes theorem, correct, that this joint concept is there. Okay, due to that we are
Okay,
moving.
yeah.
Okay,
Only for the distinct.
understood. Yeah,
Uh,
you can say
Thank you.
disjoint or mutually exclusive, both are the same terminology for this. Okay, now if you
Okay,
see
thank you.
this question, right, if you see this question, okay, let me just try to reframe with the question. What question says, in a population 45% are female, 55% are male. Okay, so that means even instead of even and E2, can I say this is the female, right? I have two part, female and male. Yes or no? Right? Well, and they are saying among female, there is one property, there is another event is happening, which is called among all the females. That means all this, you can see my pencil, left-handed, 9% are left-handed. Among all the males, 11% are left-handed, right? That means this A is nothing but now L, right? L denotes for left-handed. Now are you getting? Right? Yes or no? So question is, a person is randomly chosen from the population. What is the probability that person is not left-handed? So we know person is not left-handed. So I will denote is L complement. So this is nothing but 1 minus probability is left-handed. Yes or no? So first of all, we'll find the probability that person is left-handed. We will subtract with 1 minus. So what is the probability that person is left-handed? Let me do it again. Let me solve it. Okay. So person is left-handed means we have to, when it will be left-handed, that means person is female and left-handed, right? That means this one. Union, person is male and left-handed. That means this green part. Yes or no? Are you getting or is it you are getting bored or something? If you apply the probability part, I will get this summation sign. Yes or no? Now, so this will be probability of left-handed, then probability of, now here I can say probability of female into probability of person is left-handed given that female, then probability of male, okay, into probability of left-handed given that male. Is this fine so far? Yes, no? Right? See, if you want to speak, how I will get the idea whether you are getting the things or not? Or should we wind up the session?
So we are following.
Well, so is this fine, right? So in the question you can see it says 45% are female. That means what? This probability of F is given to us, right? Which is 45%. That is 45 by 100. And 55% are male. That means probability of male is 55%. Now you can see you have this quantity and this quantity. Now what is the next statement? Among all the females, 9% are left-handed. So that means what? I'm saying female is given to us. Among all the females, what is the probability that person is left-handed? It's a 9%. Yes or no? And then among all the males, 11% are left-handed. So we are saying among all the male, given that male is there, what is the probability they are left-handed? It's a 11%. Is this fine? This all things which are given in the question.
Yes.
Well, now, so what is the probability that person is left-handed? First, find the probability of person left-handed. So what is the probability of F? That means 45 by 100 into this part 9 by 100 plus male 55 by 100 into this part 11 by 100. So basically we have to solve this, and question is probability that person is not left-handed. So not left-handed is complement of this. So we will do 1 minus probability of left-handed. So whatever value of this will be, we have to subtract with 1. I will get the answer. Is this clear? Okay. Yes, no?
Yes.
Okay. So next question is the just another form which is called Bayes theorem. I will let you know. So what is the Bayes theorem is saying? Okay. So the information is same, right? Information is same is 45% are female, then rest are male, and this is the person of being left-handed. Okay. So when Bayes theorem is useful, right? You can see what is the question? Final question is, it is given that person is left-handed. I'm saying it is given that person is left-handed. What is the probability that person is male? Okay. So what is the probability that person is male? So you can simply apply a conditional probability formula. So it will be probability that M intersection L means male and left-handed divided by probability that person is left-handed. This probability of L we have calculated here in the previous part. Okay, but for the numerator part, okay, how can I write this numerator part? By using the multiplication rule. I can write here person, what is the probability that being a male into probability that among all the male, what is the probability of being left-handed? Divide by probability of left-handed, right? Yes or no?
Yes.
Are you getting this idea, right? So you can simply say this value is given to us. Probability of male is given to us 55 divided by 100. Okay. So this probability of male, probability of M is, it's nothing but 55 by 100. And what is this probability of left-handed M? This is 11%, right? Okay. So basically you have to just substitute the value, and probability of L is nothing but we have to calculate from the, we have calculated in the previous question. Okay. So what, this is called something Bayes theorem, right? This is called the Bayes rule or Bayes theorem. Okay. In the question, suppose I'm going to change the question little bit. What is the question? Suppose I'm saying if the person is left-handed, what is the probability that person is female? Then how should I write? Tell me in terms of notations. It is given that person is left-handed, right? Correct. This is given sign. What is the probability that person is female? This is something you have to calculate. So how I will write? Female intersection left-handed divided by probability of left-handed, right? How I can write this F intersection L? So F intersection L means what? This part, right? Right? See, F, first of all, F will be there, means this total case, right? Then L is this case. So what is the intersection part? Intersection part is this one, right? This orange one, right? So how will I find this intersection? What is the, first of all, blue one, right? Are you getting this idea, right? What I'm trying to say? First of all, what is the probability of blue one into blue one is occurred? What is the probability that this common, this is orange one? This is something we are trying to say. Is this all right?
Yes.
Or any doubt?
Yes.
Okay. So you can simply put the values. It will change accordingly. You will get the answer. This 0.599 you will get for this. Okay. Is this fine to all of you? Any doubt? Yes, no, anything? Okay, so till base, is it fine, right? So I will share this PDF with the team. They will share with you via mail. Okay, this recording of today's session and as well as this solution PDF along with the question. Okay. Okay, then can we wind up then? Okay.
Sir, we didn't get the recording of the last class.
Actually, I shared with already team. Maybe they missed, but
I have the YouTube link for that. You guys can use that.
Yeah. Okay, sure. Actually, okay. Let me share the YouTube link for of the previous session as well as today's session also. Okay. Then this is the previous one. Okay, and for today's you can just save it now. I will share with the team. They will upload it for sure. I mean, maybe they have missed out somehow, but yeah, you can take from the chat. Okay. I'm hoping you got some idea of the till base theorem. Okay. Okay, then. Well, anything else? Yes, no. Nothing.
Yes, sir. All
Okay.
good.
Well,
Okay. Thank you.
Okay,
Thank you.
thanks. Hope session was helpful to all of you. I will share the PDF. Okay, don't.
Thank you. Thank you.
Yeah,
Sure.
thanks.
Thank you.
Yeah, thank you.